أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Assalamu alaikum. Good day, learners. Join me again as we learn how to count, solve, and enjoy math. Kindly open your Module 3 with the title Numbers in Exponential Form and Scientific Notation. In this lesson, you will learn how to describe the exponent and the base in a number in exponential notation. Second, to give the value of numbers expressed in exponential notation. Third, to express positive whole numbers in expanded notation and vice versa. And fourthly, to find and compare the value of numbers expressed in either expanded or exponential form. Let us answer the following exercises. Express in expanded form using exponential notation. Number 1, 4,907. Number 2, 820,538. You may pause this video and start answering. Replay again to check your answers. Here are the answers. If you have the same answers as well, good job for you. Is the recap of our previous lesson on exponential notation. And here, as you can see, is a notation which is read as 2 to the third power or 2 cubed. And as you can also again see, it has an exponent of 3 and a base of 2. So if you have to factor this, you have 2 times 2 times 2. For its standard form, simply the product of our factors, that is 8. Okay, go back with our notation. Again, this 2 here is called the base, and the 3 here above the 2 is called exponent. We have here a given expanded form of a numbers, and what you're going to do is to express it into its standard form. So let's begin. That is 8 times 10 to the power of 9. Okay, as you can see here, our exponent is 9 and our power is power of 10. And as you can remember in our previous video, if it is power of 10 and your exponent is 9 or any other whole numbers, meaning your zeros also depends on the number of your exponent. So that will become 8 times 1 billion because you have 9 as an exponent. You also have here 9 zeros. Moving on with 3 times 10 to the power of 6, that will become 3 times 1 million with 6 zeros because your exponent there is also 6. Okay, we have also here 5 times 10 to the power of 5. That will become 5 times 100,000. As you can see, you have there 5 zeros because your exponent is 5. And we also have here 9 times 10 cubed, meaning you also have to have this answer 9 times 1000. Have 3 zeros because your exponent is 3. And our last digit 7. And it will look also like 7. Now let us multiply each term of these numbers. So we begin here. 8 times 1 billion, you got 8 billion. 3 times 1 million, you got 3 million. 5 times 100,000, you got 500,000. 9 times 1,000, you got 9,000. And okay, 7. Now let us add all these terms in order for you to get your standard form. Now, 8 billion plus 3 million plus 500,000 plus 9,000 plus 7, you got the answer of 8,3,509,007. By now, you've probably heard of a disease called coronavirus or COVID-19. But don't you know, the size of this virus can provide a useful insight into how these infecting species can harm on human cells. Researchers have determined the diameter of this virus range between 0.000000006 meters to 0.0000014 meters. In addition to measuring the spherical size of the virus particle, it has also been confirmed that the length of the size tumors that surround the outermost surface of the virus can vary in length from 9 times 10 to the power of negative 9 meters to 1.2 times 10 to the power of negative 8 meters. So, individual who ingests, inhales, or is exposed to COVID-19 particles increases the probability of infection. Therefore, each individual must take adequate steps to reduce their exposure to these particles by wearing masks, washing or sanitizing hands, and practicing safe social distance measures, to mention few. Above all, there is no best protection compared to the protection from our Almighty Allah subhanahu wa ta'ala. Always be reminded of Allah and take note, dua is free and didn't cost a single penny. So, keep safe, everyone. If you've observed from the video, there are numbers written in long decimal digits and exponential form called as scientific notation. So instead of using long decimal digits to represent numbers, scientific notation uses a shorter number multiplied by a power of 10. Don't you know, class, that some numbers are very small or very large that writing them would require much effort, time, and space. For instance, the number 1 Google, which is written and as you can see, it is very long. Now, this number is so large that writing it would be extremely time consuming unless it is expressed in scientific notation. So 1 Google in scientific notation is 1 times 10 to the power of 100. So it is now written in scientific notation. Instead of this longer version, it is already shortened. Take note, class, that there are 3 basic parts of a scientific notation when you have to write it. So first, that is the coefficient. And in coefficient, take note, it should be written from the amount of 1 to 10. Meaning, if you write your coefficient below 1, like for example 0.428, that's not already a coefficient suitable in writing a scientific notation. And also, if you write your coefficient more than 10, meaning for example you have here 12, it's not also a suitable coefficient for your scientific notation. Now, let's move on with our base. So take note, in scientific notation, your base should always be 10, power of 10. So meaning if it is not 10, for example, your base is 5 or other numbers, it's not already a base for your scientific notation. And also, we have here our exponent. And in scientific notation, in your level for now, we'll be using what? Whole numbers, that is, could be positive whole numbers or a negative whole numbers. Here is our first example. Express the number as a product of two numbers such that the second factor is the greatest possible power of 10. Notice, class, that there is no mentioned particular amount of number. So you can just randomly select any number. So let's say you have here 12 million. Wow, a very big number. What will you do with your 12 million? Okay, first, what is the possible factors of 12 million? We may answer as 12 times 1 million, right? Because 12 times 1 million is equal to 12 million. Now, what do we do next? Take note, 12 is our coefficient. Remember a rule with coefficient? It must always be a number from 1 to 10. Is 12 from 1 to 10? No. How do we deal with this? Well, we'll have to turn our whole number 12 into a decimal number. But how? Listen, 1 is our tens and 2 is our ones. Now, we'll figure out where is the decimal point. It is right here, immediately to the right of our ones place. That is after number 2. Move ones to the right and put a decimal point after the first digit. It appears as 1.2. Is 1.2 from 1 to 10 already? Yes. Next, how many times do we move again? Just once, right? That means we add 1 zero in our 1 million. That makes sense, right? The more you move, the more you add zeros. From 1 million, it becomes 10 millions. You add 1 zero because you move once in 1.2. Alright, let's express 10 million in its exponential form. Let's first bring down 1.2. Now, write the power of 10. But first, let us count the number of zeros. How many zeros do we have here? It's 7. So simply put, that will be also the value of our exponent, 7. Simply put, this is the scientific notation of 12 million. That is 1.2 times 10 to the power of 7. We have here our second example. Express the number as a product of two numbers such that the second factor is the greatest possible power of 10. Express your answer in scientific notation. So a while ago, we used a large amount of number, and that is 12 million. Now, let us use small amount of number. And let's say that is 0.000000056. What might be the possible factors of this number? That is, let's say, 56 times 0.000000001. You have to multiply this, you will get the above number. What do we do next? We will turn our whole number 56 into its decimal number. But how? Listen again. 5 is our tens digit and 6 is our ones digit. Now we will figure out where is the decimal point. It is right here, immediately after our ones place, that is after number 6. And now we will move ones to the right and it appears as 5.6. Now is 5.6 from 1 to 10 already? Yes. Alright, let's move on with the another factor. In our second factor, remember we move 1 place in 5.6, right? So meaning in our second factor, you will remove here 1 0. So it will become like this. Now, okay, let's bring down again 5.6 and let us express our second factor into its exponential notation. So we write first the power of 10 and what we will do next? We will move our decimal point until it reaches 1. We say 1, 2, 3, 4, 5, 6, 7, 8. How many times? 8 times. So our exponent will also be 8. So in here, it will become negative 8. Let's simplify our discussion to clear things. So first, we have here 12 million. To write its scientific notation, we simply move our decimal point to the left. So let's start counting. 1, 2, 3, 4, 5, 6, 7. It will become 1.2. Now, teacher, can it be 12? So remember, our coefficient should always be from 1 to 10. So if it is beyond 10, it cannot. But teacher, what if it's 0.12? Can it be? So remember again, if your coefficient is below 1, it cannot. So remember again, how many times do we move? 7 times, right? So we say our 10 should be raised to the power of 7. Okay. Second, we also have here 0.000000056. So many zeros. Now, to write its scientific notation, we simply move our decimal point to the right. We start counting. 1, 2, 3, 4, 5, 6, 7, 8. That will become 5.6, right? Now, what we will do next? Teacher, what about 56? Can it be also instead of 5.6? Remember again, coefficient above 10 is cannot be. So, no. Teacher, can it be 0.56 instead of 5.6? Again, coefficient below 1 is cannot be. So it's no. So again and again, we times it, we multiply it with power of 10, and how many times do we move? It's 8 times, so that will be our exponent. But this time around, it's negative 8. Teacher, why it becomes negative? Let's go back with our 12 million. Remember, we moved to what direction? to the left. Remember, if you move your decimal point in left direction to the left direction, meaning your exponent is positive. That is why here your 7 is in its positive form. While if you move your decimal point in what direction? To the right. If it moves to the right, meaning your exponent will become negative. That is why your exponent here becomes negative 8. So I hope it is now clear for you. Now let us express scientific notation into its standard form. We have here 4.2 times 10 cubed. Take note of your exponent. It is positive and it is number 3. So meaning you will move your decimal point to the right 3 times. We say 1, 2, 3. And what will you do is to place these empty spaces, these empty places into 0. So it will become 4,200. So this is now the standard form of your scientific notation. And if you observe, your exponent is positive and you move your decimal point to the right direction. So again, another example, we have here 3.2104 times 10 to the power of negative 4. Take note of your exponent. It is negative and it is number 4. So meaning you will move your decimal point 4 times to the left. So we say 1, 2, 3, 4. And you fill these empty places with zeros. So it will look like this. So this will be the standard form of your scientific notation. And as you've observed, if your exponent is negative, the direction of your decimal point when you move it is to the left. I understand, class, that it is very tricky, but so long as you are very careful, you will see to it that these expressions is just easy peasy. So let's summarize. So as you can see here, if you will express a standard form of a number into its scientific notation, and when you move your decimal point to the left direction, meaning your exponent will become positive. As you can see here, it is positive 7. And when you move your decimal point to the right direction, meaning your exponent will be negative. Now, on the other hand, scientific notation to standard form. As you can see here, if you move your decimal point to the right, meaning your exponent is positive. While if your exponent is negative, then you will move your decimal point to the left. So you can simply pause this video and you can analyze, rethink, absorb this new concept regarding scientific notation, and you can just again replay this after. Now, I want you to study the further enlisted examples in your module, and after that, kindly answer your seat work in your worksheet on exercise set 1 with this icon. And for your assignment, kindly answer it on your worksheet again with this icon.
بسم الله الرحمن الرحيم والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر.
سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.